Okay, if you're watching this, you should be up to page 14 in your climate and groundwater notes packet, and you should have done all the problems and watched all the videos and not just rush ahead, because you will be lost if you do that. So now, the next thing we're going to talk about is another factor that affects climate. We've already gone through several of them. Okay, now we're going to talk about mountain barriers. In other words, if you have a mountain range or a large mountain in your environment where you're living, how does that impact the climate? Okay, so for instance, here in this picture, you will see an ocean over here, and it shows the winds blowing off the ocean. And obviously, the wind cannot go through the mountain, so it must go up the mountain, over, and then back down. The side that is receiving the wind is called the windward side, and the other side is always called the leeward side. So we're going to go through this in detail right now. All right. So this is referred to, the thing we're about to talk, as the orographic effect. I'm really not going to use that term very much, but I just wanted to throw it up here, because when we talk about windward and leeward sides of a mountain and how the climate is different, the mountain produces this thing called an orographic effect. All right? Yeah, that's just strange. Okay. All right, so the orographic effect is just a change in the climate caused by mountain barriers, as we just stated. Okay? The windward side is not the left side. It is also not the right side. It is also not the side that has the water. The windward side simply means the side of the mountain where the wind is coming from. Now, in this case, there is in fact water, and it is in fact on the left side, but it doesn't have to be. The windward side is just the side of the mountain where the wind is coming from. All right? So as the air hits the mountain and starts to go up, okay, as you know, as air rises to higher and higher altitudes, it cools down, eventually hits the dew point, produces clouds, and clouds typically produce precipitation. So on the windward side, the air rises, expands, cools to the dew point, as I just said. That creates a more moist climate on that side of the mountain. Okay. Now, as the air travels over to the top, and then it's going to start to go down, you're on what's called the leeward side. Okay, basically the exact opposite happens. The opposite of rising is sinking. The opposite of expanding is compressing. The opposite of cooling is warming. And that's what happens. The air sinks, compresses, and warms, and you'll notice there are no clouds on this side. Most of the water vapor was wrung out of the clouds, out of the air on this side with the rain, so the other side is basically the opposite. All right? So on the windward side of the mountain, you typically have cooler temperature, and you have more humid conditions. It's more moist. On the leeward side, literally the complete opposite. Warmer temperatures and drier. The term we've used to describe dry is arid. Drier or more arid conditions. Sometimes they're called rain shadow deserts. All right. Here's another picture showing two different sides of the mountain. Here is a real picture of an island from up above. If you had to guess which side was the windward side and which side was the leeward side, what would you think? Okay. Notice all the vegetation in the green over here. Notice the brown, more drier appearance over here. This, by the way, for those of you that are really looking, some might think that is snow. That is not snow. It is, in fact, clouds. We are just really high up looking down. So this is the windward side. The wind is coming from this direction. Windward side and then leeward side. Two different, totally different climates, sometimes referred to as microclimates, different climates in a relatively close area. All right. Now, on to the next page. If you go to page 15, there are actually questions that you should be answering, but I'm going to skip those right now. You're going to do those on your own, and I'm going to do the last portion of this part of climate, okay? And that is, how does a climograph illustrate the climate of a region? A climograph is basically just a graph that demonstrates or models what the climate is all about, okay? So for instance, here, This is a climograph for the equator. When we talk about climate, we're interested in two things. We're interested primarily in temperature and precipitation or moisture. So we actually have two different graphs going on here together. One, we have the temperature line, which is this line, and secondly, we have this bar graph for moisture. We're probably going to focus most on this line, but this line is important as well. Now, if you look carefully at this climograph, which again is just a graph showing temperature and precipitation in City A. In this case, City A is in fact the equator. Now, what information is present on this graph that would make somebody think that you are at or near the equator? Well, first off, the temperature is high all year long. Now, this says 25 to 30 degrees, but recognize that's in Celsius, so that's actually quite warm. There is not a large range, meaning that the temperature is high basically all year long. That tends to happen near the equator because of the more direct rays that they receive. Also, you will notice down here that there is quite a bit of precipitation. And if you recall from one of the earlier videos, if you're near the equator, that is a low pressure belt with a lot of moisture. Okay, so you should recognize that pretty straightforward. City B, look at this place. Now this clearly has a larger temperature range going from -8 or so all the way up to about maybe 16 or 17 degrees Celsius. So that's a fairly large range, not near the equator. All right. This is typically a graph you would see for a place like New York or any other place in a mid-latitude location somewhere in the northern hemisphere, right? They have warmer summers and cooler winters with more of a range, and there is a moderate amount of rainfall, but not as much as there was on the equator. All right. So average temperature range with seasons, right? This is a temperate zone. They have distinct seasons. All right. The third place, now look at this carefully. What do you think this represents? It kind of looks similar to the last one, except for one major difference. Okay, it's reversed. All right, and it's reversed because you're in the southern hemisphere. In the southern hemisphere, obviously, in the months of June, July, and August, it's colder. It's their winter. And in the months of January, February, and December, that is their summer. So it's quite a bit warmer then. Okay. The graph shows the opposite seasons of the northern hemisphere. I hope I didn't just misspeak. All right. This is the North Pole or an Arctic region. Notice the temperatures are cold all year long, but there still is a decent range. It goes from extremely cold to just cold. This is because of the Earth's tilt and the revolution around the sun. During the summer months, the Arctic regions are mostly or always in light, and in the winter they are always or mostly in darkness. So that would give you a big range, although even at its warmest, it's still not particularly warm. You'll also notice that there's very little precipitation near the poles, and we talked about that on the other video as well. Okay. All right, and that is it. I'm going to stop here. That basically ends climate. You have some more information coming, some more work that's going to be uploaded, and you definitely have problems to do now on page 17. But that is the end of climate, and the next thing we will do will be groundwater.